I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here is a very important question based on transformations. It is important from also test point of view. So all those in grade 10 who are going to take test on quadratic functions, they should really watch this carefully. When a graph of y equals to x squared is transformed, the point 39 moves to 817. Describe the three sets of transformations that could make this happen. Now this question has been shared by my student and I hope its solution will benefit most of you. We'll understand the basic concepts of linking original point with the image points with the help of this particular question. You can always pause and answer and then look into my suggestions.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now before we get into the details of answering this question, let us understand the concept of transformation. We are talking about y equals to x squared. And when we say a transform function, how will that look like? Let's write that. The transform function could be, let us say, f of x equals to a times x minus h whole square plus k. So that is generally the transform function when we talk about quadratic functions. Clear? Now if that is the transformation, then how are the original and the image points related? Let's write that down. Well, the original point could be xy. In that case, horizontally, there is only one transformation here, and that is the x point moves h units right. That means the x coordinate will increase by h. However, the y coordinate can be vertically stretched or compressed by a factor of a, means multiplied by a, y value, and then translated up or down by k. So add k. So that is how the transformation can take place. Now, this actually relates to the 2 points which are given to us. So in our case, we have the original point which basically is 39 and we want to change it to 817. So that becomes the image point. The question really is, what kind of transformations can take place? So the answer is there could be many types of transformations, right? So we'll give some solutions to this. So once again, what we are given here are coordinate points 3 and 9, which are translated or transformed, I should say, into 817. We need to figure out what kind of transformation could take place. So as I was saying, the transformation general formula will be f of x equals to a times x minus h whole square plus k. This is because the parent function is y equals to x squared. In that case, the transformation is from xy to what? The x value is increased by h, right? and the y value is multiplied by a and then increased by k. Of course, when k is negative, it will be decreased. Now, if you look into this combination, one part is clear. Since the only change which takes place in the x values, let's try to relate these, right? What do you notice? Well, clearly, we are changing from 3 to 8. And this change really is increased by 5. Increased by 5 means horizontally translated by 5 units, right? So we can write this down. So we have a horizontal translation five units, right? Now, as far as the x values are concerned, since we have taken a very simple case where there is no horizontal stretch or compression, the only change is of 5 units. Perfect. So in this case, we have mapped these two, and we are very clear that as far as the horizontal related transformations is concerned, 5 units right is one solution. Now, what could be the solution for y? Now in y we have got two parameters, one being a, the other one k. So their combinations will give you many results. And that is why we want you to describe many sets, not just 3, right? So the question is really asking for 3 sets of transformations. 1. All these sets will include this particular translation of horizontal 5 units right. But vertically, we could multiply by something and then move up or down. That is what you need to focus on. I hope this concept is absolutely clear. In case you want to learn from me, you can always send an email on the address given. Now let's try to see what could be different cases. So we'll give solutions one by one. So one part we have already cleared, which is 3 squared is 9, right? This is our function y equals to x squared. Definitely, it's a original point on the graph of y equals to x squared, and it has now moved to 8, 17. So definitely, we have an equation of f of x which is kind of a times x, and the y value, because it has changed 5 units to the right, means 5 whole square plus k, right? So that is the case. So we have fixed 1, which is horizontally translated 5 units right. So we are now going to focus on the other one, which basically is changing 9 to 17. How is that possible? Great. So we have also seen that xy quadrants will actually change to xy being increased by the value which we have decided as 5, right? And a times y, which is 9 for us, right? A times 9 plus k, right? A times 9 could be written as 9a plus k. Is that okay? Right? 9 times a plus k. So that is the y value, and we want this value to be what? We want this value to be 17. So we are working on the equation that the y value of 9 when multiplied by a and added by k, we should get 17. You get the idea. That is what the y coordinate is transformed. Now, this could happen in many different ways. If we assume a to be 2, for example, then what happens? If I write a equals to 2, in that case, I get 9 times 2 plus k equals to 17, or k is equal to 17 minus 18, which is minus 1. So that means we come up with a solution of vertical stretch by factor of 2 and vertical translation one unit down. Correct? So we get one of our results, right? In that case, the equation could be f of x is equal to a value is 2, and we know that x, we have gone 5 units to the right, and k is 1 unit down. So that is one possible solution. You get the idea, correct? Now let's look into other possible solutions, right? So now, the other possible solutions could be what? So we are saying our function f of x, once again, is a times x minus 5 whole square plus k. So we already matched 3. Now we are matching 9 and 17, the y values, right? So we already have 3 and 9 matched to 8 and 17. So we know this 5 helps us to get 8 directly. Now we're looking into 17. So the alternate method could be that we could give a times the original value of 9, that means 9a plus k, and 9a plus k is 17, right? Now, if I say that a is, let us say, minus 1, let's work out, a equals to minus 1. In that case, what happens? If a is minus 1, then we have 9 times minus 1 plus k equals to 17, or k equals to 17 plus 9, which is k equals to 26. Make sense? So we have another transformed function, which is f of x equals to the a value being minus, and we have x minus 5 translated 5 units, and k being plus 26. Do you see that? So horizontally, we have moved 5 units to the right. Vertically, we have moved 26 units up, while in between, we did reflection on the x-axis, right? Like this, you could give many solutions, right? Now, here is the last one for you. We are going to move from 3, 9 to another point, which is 8, 17, which is the image point. So we are saying that 9 times a plus k should be 17. You could give any value to a and then work out the k value. You get the idea. Or you could also give a value to k and get the value for a, right? Anyway, it's easier to put a as some value. Let's put 3 here. So in that case, 9 times 3 plus k is equal to 17. So what is k equals to? K will be 17 minus 9 times 3, which is 27, and that gives you k as minus 10. So we get another answer, and that is, we can now write down that the function could be, when a is 3, then be x minus 5 whole square minus 10. You get the idea. So when I give you the equation, you should be in a position to write down the transformation in this fashion. So what are the transformation? We are saying vertical stretch by a factor of 3, translate 5 units right, and translate 10 units down. Does make sense. So likewise, you could describe the other transformations, which I didn't. Plus, you can add your own solutions with this particular concept. I hope you find this interesting and useful. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that would be great. You can always send an email on the address given to learn more. Thanks for your time and all the best.